Question number one, I'm already having some questions about this one from two of the blocks. This is one of the ones I was talking about when I posted this, that this is a little more subtle than what PowerPoint can really get across. This is a good question for us to kind of use as a teaching opportunity. So a light wave travels from one medium into a second medium, so that might be from light into water. Could be from air into water. It could be from air into glass. We don't know. It doesn't matter. Point is, it has a greater absolute index of refraction. Again, that isn't going to impact our answer. It could have a lower, it could have a greater. It doesn't really matter. It's just saying it's different. Okay, so that means it's going to affect, if you read through the PowerPoint, it's going to affect the speed of the wave. So which thing will remain the same? Which thing won't change? So the answer here, I'll tell you already, is going to be frequency, but I want to talk about why. So let's have a look at the whiteboard. So the thing that's important here to remember is that the speed of the wave is equal to its frequency times the wavelength. Right? That's the important equation here. When the wave is created, all of those three things had a defined value, and if one of them changes, the other ones must change in order to keep it the same. Now, this is natural. If you're a sound engineer, there's things you can do to sound waves to manipulate them outside of this equation, but we're dealing with waves just traveling around on their own, going through different materials, stuff like that. So the one that's going to stay the same is frequency, and the reason why is because if you think about what creates a wave, right? So I'm going to use an example in a second. I'm going to use a mechanical wave. I'm actually going to use C waves. If you think about what creates a wave, it's actually something moving back and forth or up and down, something, some kind of oscillation, and that is what sets the frequency. So this is dictated by the source. Okay, so I'm going to show you how this might work with an example you're probably all quite familiar with. Now, you know my drawing's awful, so please forgive me. So here's my my water. Here's my person bobbing up and down. Okay, so we're going to set this person. It's going to kind of jump up and down as you do when you're in the sea, right? Having a bit of fun, jumping up and down. So we're going to say that it's quite deep here, and then it becomes quite shallow as you get towards the shore. Right, so this person jumps up and down, and what they do is they create a wave. Right, I'm just going to draw the first part of it for now. Should be the same height. Okay, so we're going to assume that's the same amplitude. I didn't mean to draw it differently. I just can't draw very well. Let's say that wave is moving at 3 meters per second. Right, so that's my wave speed. It's moving at 3 meters per second. It has a set wavelength. It has a set frequency. All right, but what happens is when it gets to the shallow, is it slows down. Right, so we've all seen this. As you get to the shallow, the wave slows down, and what they do is they bunch together. Right, I'm trying to draw them the same amplitude. I'm just not very good at drawing. Let's say it slows down to a speed of 1 meters per second. All right, this is. I'm not just making this up. This actually happens, right? Waves out in the open sea travel a lot faster, and then when they get to the shallow, because of the resistance from the ground, they slow down. Well, what else do we notice? They've also bunched together. So what's happening is my frequency was set when I bobbed up and down in the ocean. That frequency remains the same. If I slow this down, right, you would expect less waves to pass by me, right, because it's slowing down. But the other thing is the wavelength is decreasing. So that means even though it's moving slower, right, the same amount of waves are going to pass by me because the waves are much shorter. So my frequency is going to remain the same, but my wavelength is going to decrease and my wave speed is going to decrease. So these two can change depending on the material. So if you think about it as a light wave, if I shine some light at some glass, it's going to slow down, right? It's going to make it bend. So this is going to slow down. This is probably going to slow down a little bit, or decrease a little bit, sorry. And that's going to keep my frequency the same. So it's just something you really need to remember here, but this is kind of my explanation as to why. So the answer is frequency will stay the same. You can see you can affect your wavelength, you can affect your wave speed, but your frequency is set at the source and that cannot be changed. Okay, so the answer to question 1 is answer choice 1. Hope that helps.